Hello everyone, welcome to the standard of complex mathematics. We want to see how we can express f of z is equal to exponential z in terms of u plus iv. So to begin with, we are going to use the fact that z is equal to x plus I y. We are also going to use the fact that exponential ix is equal to cos of x plus I sine of x. This is Euler's formula, and this is the definition of a complex number. So we are going to make use of those two substitution here. So f of z is equal to, instead of z, we substitute it with exponential x plus iy, which can be written as exponential x multiplied by exponential iy. Here I have made use of laws of indices, which tells you that if you have a power n plus m, this is the same as a power n multiplied by a power m. So I have made use of that rule of indices in this part here. Then using this Euler's formula, we are going to have the following. We shall have exponential x into bracket. Instead of exponential iy, we substitute it with this Euler's expression. So we shall have cos of y plus I sine of y. Then we can remove the bracket by multiplying with the exponential x throughout, so that we are going to have f of x cos of y plus I exponential x sine of y. Then here we compare with the fact that f of x is equal to u is a function of x and y, plus iv, which is a function of x and y. So clearly, when you compare these two here, you can see our u will be equal to exponential x cos of y, and our v will be equal to exponential x sine of y. And so when you compare those two, is that we have already proven what we are required to do. Also, part 2 of this, given that f of z is equal to cos of hyperbolic of cos of z, we write this in terms of u plus iv. So we are going to have f of z is equal to hyperbolic of cos of z, which is equal to hyperbolic of cos of x plus iy, which will become cos of hyperbolic of x hyperbolic cos of iy, then plus hyperbolic of sine of x multiplied by hyperbolic of sine of y, sine of iy, and there is I outside there. Now at this level, we are going to make use of the fact that we have found out that cos of I y is the same as hyperbolic of cos of y. So that is one of the factors we are going to use. We shall also use this factor that when you are given hyperbolic of I sine of y is the same as sine I of y. So making use of this fact, we are going to find that f of z is equal to cos of x multiplied by, this is a parabolic cos of x. Here we have hyperbolic cos of x multiplied by hyperbolic cos of y plus I hyperbolic sine of x multiplied by sine of y. Then we compare this, f of z is equal to u, whereby u is a function of x and y, and v of x is a function of x and y. So comparing, you can clearly see that our u will be equal to hyperbolic cos of x multiplied by cos of y, and our v will be equal to hyperbolic sine of x multiplied by hyperbolic multiplied by sine of y. So clearly now our f of z, you are given as cos of hyperbolic cos of z. We have clearly expressed it as u plus I v, whereby our u is hyperbolic cos of x multiplied by cos of y, and our v is hyperbolic sine of x multiplied by sine of y. So thanks so much for taking your time to study with me. For such learning, kindly tune on to my YouTube channel so that we may continue learning together. So also remember to subscribe to this channel so that you don't miss a single video which I upload for us every day.